Hey guys, welcome back to AlgoYogi. I know what you're thinking. It's too early for Christmas, I know, but it's not too early for solving a LeetCode problem. So let's solve our next tag series problem, which is online stock span. Let's go to LeetCode and give it a read. It's a bit of a description right here, but I'm telling you guys, it's super simple. All right. So it's a design problem. You can see like they're given us a class stock spanner. Okay, so design an algorithm that collects daily price quotes for some stock and returns the span of that stock's price for that current day. All right. So the span of a stock's price in one day is the maximum number of consecutive days starting from the day and going backward for which the stock price was less than or equals to the price of that day. So they have given like this example right here. Then we will be implementing stock spanner class. Basically this initializes stock spanner, and then this next function will be basically taking the price for the current day and returning the span for that current day by looking at our data structure that we will mention in our init function. So let's get into it and understand what they're actually asking us. Here is the stock prices. I've just written them in an array, but remember they will be given to us as in the form of basically this next function. One by one they will be giving us these prices for that day, and then we will be returning the span for that day. So let's find out the spans for all these given prices, stock prices. So let's find out spans. Let's find it out as an array, but like remember they will be passed with the next function. They'll be giving to us one stock price for that day, and we will be calculating the span for this and returning that span. But here let's just calculate for all of these. So how many prices before 100 you see that are less than or equals to 100? It's just including itself also, so it's only one, right? How about 80? That's also 1. 60, that's also 60 itself, so because 80 is not less than 60. How about 70? Yes, 60 is less than 70, so 70 itself. And then 60, is 80 less than 70? No, this is what we are comparing with, but continuously consecutive days. Okay, so here it's going to be 2 because 60 and 70. How about 60? 70 is not lesser than 60, so it's also going to be 1. Now how about 75? This is tricky. So 60 is 1, 60 is 1, 70 is another because they're both less than 75. So now there are 3, basically 75, 60, 70. These are less than or equals to 75. So 3 spans so far. 60, yes. 80, no. 80 is greater than 75. So it's going to be 1, 2, 3, and 4 for 75. So that will be 4. How about 85? Well, for 85 it's going to be even more because 85 itself 1, then 75, 60, 70, 60, and then 80 but not 100, so 6. So that will be our answer spans, but we'll be returning them like 1, 1, 1, 2, 1, 4, 6. So we need something to basically keep a track or like to store all of these prices for us, right? Because at once we will be given to us like just the price, but we'll have something to store it. Okay, so I think this is the brute force approach where you are calculating it for one of the prices, but you are storing for big of n time complexity, space complexity. You are storing all these prices, whatever is being asked to us in your next function, and then you are, for that price you are going backward right from the beginning, or maybe like from a particular price, let's say from 75, you're going back into the array for checking that how many consecutive days it is seeing that are lesser than or equals to this. So this is going to be, time complexity will be big of n square. Can we do better? Yes, we can. That's why I called it a brute force approach. So how do we do it? Well, there is this great data structure that this problem is part of that series, which is stack. So let's use stack to basically go from beginning to calculate the spans for these prices and store them in our stack. And while we want to calculate for our next day price, we will just look into our stack top and see if we have seen some lesser or equals to prices before that, and how many. So we'll have to store two things. So I'm gonna have stack, and then stack will be storing our prices and spans. Okay, and then we'll just return the span for that day. So I'll just also have span right here. Okay, like this. Okay, so for 100, how many stock prices before 100 do you see that are less than or equals to? We already done this, so it's 1. So I'm going to store 100, and I'm going to store 1 because that's the number of spans I have seen, including 100 or before this. Then for this, I will be returning the span 1 because that's the answer. Then for 80, what I'll do is I'm gonna check on the top of my stack that if this price, the price that I have seen before, which is 100, is it less than 80? It is not. So what do? I will again keep 80 as 80 and then 1 as its span, because that's the only stock that is less than or equals to itself. So the answer will be 1 again. For 60, I'm gonna again have check, is 60 greater than my 80? No, it is not. So this will also be 60 and 1. The answer would be 1 for span. So this is what we are returning with the next function. Then for how about 70? For 70, if you see the top of my stack 60 value, that is less than 70. So that means whatever span 60 has seen so far, that will belong to 70 as well, because 60 is lesser than 70. So 60 has seen some consecutive values that were less than or equals to itself. So I will pop this value and add the span to my 70. So let's say if span I'm calculating right here, initially it was 1, I popped that value, I popped 60 and added that span to it. So I'll be adding this, so 2. Now this is gone. How about the top of my stack now is 80? Is 80 lesser than 70? No, it is not. So I'll just keep that at top of my stack. But now my answer would be 2, but I'll also push that value and make this my top of my stack, 70 with 2. Okay, now we're gonna go to 60. 60 will have again 60 and 1, and then this is the top of my stack. Now answer will be 1 here. For 75, you can see 60 is less than 75. Now I'll calculate this span for 75. So span, currently it's 1, but then I'm gonna pop this off and then add that value to basically my current span that I'm calculating. 70 here is again lesser than 75, so I'll pop this off and add its span to basically my current span that I'm calculating. Then I see 80 is not lesser than 75, so currently I have calculated 1 plus 1 plus 2, so the answer here would be 2 for 75, and then I'm gonna push this as 75 and 4. Oh my god, this is not 2, this is 4. Yes. Then I'll be calculating for 85. For 85, you can see that this is lesser than 85, so I'll just add that to my span. Current span will be 1. Then I'm gonna add 4, pop this thing off, pop everything off from here, then check 80 is less than 85, so I'm gonna pop this also off and then add that to my answer. Now 100 is not lesser than 85, so that's it. And here finally I will append that 85 with answer 6, because 1 plus 4 plus 1, 6, so final answer would be 6 right here. And then this is the current state of stack, okay, this being the top, but we are out of all the days. This is what we will return, but one by one with the next function. This is going to be of big of n time complexity and big of n space complexity, so we will be just definitely brought down the time complexity from big of n square to linear time complexity. Okay, so this is an easy straightforward approach which uses a stack, and we are going to implement it like right now. Okay, so I'll have stack, so I'll just call it self.stack. I think you can see like this. Then I am being given the price for the current day, so for that day span would be itself 1 because it's less than or equals to itself. Then I'll have while stack has some value, so while self.stack and stack self.stacks top self.stacks top, what is the top right now? -1. That's how you get the top. Its first value, that's where I will be storing the price. The price is lesser than or equals to my current price. If this is the case, then I will basically pop these values from the stack. So I will append to my span plus equals self.stacks value. Before I pop it, let's get its span, what I'm popping out, because it's less than or equals to my current price, so that will be at first index. That's what I'm popping out. And then let's have self.stack pop. Okay, easy peasy. And then finally I'm going to add, but before I return, so I'll be returning the span, but before I return it, I want to save it to my stack for future prices that will be asked to me, okay, or asked to you guys. So I will have self.stack.append. What are we appending? We are appending the price, and for that price the span that we have just calculated. So span, remember, span, even if there is nothing in the stock, or it sees that there is the top of the stock's price is not lesser than my current price, so at least it will be appending 1 to it, because that's the ask of the problem. So I think this is it. Let's zoom out and run it on our example test cases. Okay, well, it's accepted. Let's submit. All right, so what's the time complexity? Well, for the entire algorithm, where all of these input is given to us, where there are n number of next asking us for the spans of all the n number of stock prices or days or whatever. For that, it would be time complexity will be of size, not size, big of n, which is linear time complexity. How about space? Well, space is also same. Space is also same, big of n space complexity. Well, this was easy solution. I know the video is long just because we had to go through all of this, description and the approach, both approach. The The other approach definitely was basically storing all the prices, but then checking from the current price, going back how many consecutive less price we could see than the current price. All right, so let's go back to AlgoYogi and mark this solved, and see you guys later in the next problem. Okay, bye-bye.